I think that we can slowly get started. So hello everyone, and thank you for joining this info session. So today our plan is to introduce you to our European CISPA Hackathon Championship. And this session is planned to be 1 hour. So we will go through the plan for this hackathon in Stockholm. We'll tell you more about the background that you will need for solving the tasks. And also at the very end, we also discuss how you can use the GPU so that you can really solve the tasks. And also we will be happy to answer any of your questions. So during the presentations, if you have any questions, we recommend that you just open the chat and you just type your questions so that people can also see in general what is for you of an interest, and we can then here moderate this session and then answer your questions. So I think that people are still joining slowly but steadily. However, the plan was that we will start sharp at 5 p.m. and we have time until 6 p.m. So I think that we can just get started with our presentation. Okay, so before we dive deeply into the content of this hackathon, first we would like to tell you more about who we are. So who are the people really who are behind this European Championship? So first from me, so my name is Adam Dziedzic, and currently we are both actually faculty members at CISPA in Germany. And before joining CISPA, also we were together in Toronto. Over there, we were postdoctoral fellows at the University of Toronto and Vector Institute. And in my case, before joining Toronto, I had done my PhD in the US at the University of Chicago. I also did a lot of different. Sorry, I think that our slides are moving. So maybe wait a second. Hmm. Okay. Okay, so I think that now it should not move automatically. So before that, also before my PhD, also I did a lot of different uh, work related stuff. Meaning that, for example, I also work at Google, Microsoft Research, and also in a bank in London. And maybe a bit more about Franziska.
Yeah, I think you said it most. I'm Franziska, and before being in Toronto, actually, I obtained my PhD from Berlin, where I also worked for the Fraunhofer Institute for Applied and Integrated Security. But it's not just us for the hackathon, but additionally, you have this whole group of people who are our PhD and master students, who are doing with us this hackathon, have developed much of the technical infrastructure, and help us proposing and implementing the tasks. And those are also the people who you will be meeting at the hackathon itself. We will all be there for you during the whole time to answer your questions, to help you get started, and help you get unblocked in case anything gets difficult. Now, let me also briefly mention about CISPA. CISPA is the institution that is behind the European Championship, and CISPA is a research institute located in the beautiful city of Saarbrücken, which is here in the border region with France and Luxembourg. And CISPA is a very international community with more than 700 employees from 66 different nations. And we all do something at the intersection of security and machine learning, which is also the main focus of the hackathon. And currently, we're more than 40 faculty members with their respective research group doing research in any kind of these aspects that you will also be discussing. And there's one thing which is particularly great about CISPA. If you look at CS ranking, which is the standard ranking platform to grade CS programs throughout the world, you will find that CISPA is #1 worldwide in the category of cybersecurity. So we're above all the other big American institutions, and really like mark an incredible score showing that the research that you can do at CISPA is at the cutting edge. So to also tell you more about one particular group, namely Adam and my group, we are from the SprintML-Lab. And our research is exactly at the intersection of what CISPA is doing. Namely, we do secure and private, but also robust, interpretable, and trustworthy machine learning. And our group alone are roughly 20 members from all levels of seniority and 8 different nations. And if you're curious about opportunities also, then just please check out our group's website. So today we're here to talk about the Stockholm hub for our Hackathon Championship. And Stockholm is the third regional hub that we are going to. Overall, there are going to be 6 events. And Stockholm is our third. We have been already in Paris and Vienna, and the hackathons over there have been big success. And what is happening is that among all the locations that we're going to, we will have the similar type of competition, and the 3 winning teams of each local hub will qualify to attend the grand final at CISPA in July next year. And if you're among those people who make it to the top 3, then we will sponsor for you the travel to attend the final. And if you win the first place, you get 4,000, the second place 2,000, and the third place 1,200 euros per team. But everyone who qualifies, so everybody who makes it into these first 3 local winners, they will get a runner-up prize of 400 euros. And what are you going to expect during the hackathon? Well, a hackathon is a 24-hour event where we'll be starting on Saturday with a registration and some small snack provided. And then at midday, we'll be having an opening session with some plenary information where we give you some talk about the real tasks that will be happening and about infrastructure and everything else that you'll be needing that day. And after this talk, the hackathon will begin. And then you have basically 24 hours to solve the task. So people have been asking if they can go home during the hackathon. Of course, you're free to leave. However, what we have seen is that the teams who won the local hubs, they stayed and they worked on their solutions the night, because then you have a few hours advantage over the other teams. So we'll be hacking the whole night, and then at 8 a.m. the next day on Sunday, breakfast will be delivered. And we'll have again until 12:30 when the hackathon ends. And then while you are having lunch, the top teams, the top 6 teams, will be asked to prepare a small presentation, 1 slide per task on their solution. And those 6 best teams will then present their solutions to everybody. And the jury then will meet, and based on your scores from the task and based on the score from your presentation, we will determine the winners and announce them in a big award ceremony. If you have questions before the event, please join our Discord channel. You will need to join latest during the event, because all the announcements regarding the tasks, regarding the food and everything will be made over Discord. Also, our team will be available through Discord the whole night, such that you can contact them there if any questions pop up. So if you haven't done it yet, please feel free to join the channel there. And what's more is that we'll be automatically evaluating your task. This means we have a scoreboard. So eventually, all the 3 tasks that you'll be working on are going to be evaluated based on some metric that we introduce the day itself with the tasks. And so you can follow up in a live version how your scores compare to other teams. And what's about a scoreboard is that there is a split, like a train test split in machine learning, where we evaluate your results during the hackathon on some part of the data, and you will be getting your results on this part of the data. And then during the final evaluation, we will swap and evaluate on the other data. And this prevents you basically from having solutions that just overfit the data that is evaluated on.
So maybe at this point, if you have any questions regarding these technical aspects regarding the scoreboard or the schedule of this event, you can always ask this question on the chat.
Or just unmute yourself and ask, that's also possible. All right, I can't see any question. So if anything becomes unclear later on, you can also still ask later on. Otherwise, we'll be moving into some of the background. And this is for you. There's a question. Yes, this information from the Zoom session will be made available. We are recording the session here, and then basically we'll be uploading this video for you to rewatch if you need this information again. All right, then let's dive into a bit of the research background. And this following part is provided to give you some understanding of what are going to be the topics of your local hackathon. So this is for you to already be prepared to take out some research and read up on these topics, which will give you a head start. And the first topic that we'll talk about is so-called data extraction. And the motivation behind that is that if you have nowadays a lot of training data that we generate, this can be photos or this can be messages, and then you take a model, for example, a diffusion model, this model is able at inference time to reproduce its training data one on one. So with an extremely small distance to the original training data. And this is because the models can memorize that training data and then later on regurgitate that. And what's the problem with that is if the data that the model has seen during training is private or intellectual property, then this might be a violation of privacy laws or intellectual property rights. And the problem is that we observe that the more the model quality increases, so does the privacy leakage, which means that the better the models become in generating images, the more closely also those generated images can match to the training images. And the methodology that people use nowadays is that they just take these generative models and then generate a lot of images and then they compare that to the training data, sometimes with some attacks that tell them whether or not a given sample was used in training. So basically what happens is that all the private data you have, whenever it goes into a machine learning model, then it like is kind of learned by the model. And what the model does is that you give it the right labels and the right images, and then you back propagate the loss such that like even simple models can learn your data distribution. And what happens in this process is that the model kind of incorporates knowledge about the training data. And that, of course, might be a problem that during training, private information is observed. And privacy leakage can then happen later on from the parameters or from the model prediction. And what attackers can do in this case depends on what they know, but oftentimes we assume that the attackers might know the model architecture or some data attributes, some data distribution, or training hyperparameters. And all this knowledge can help attackers to better extract some data from the models or some information from the data from the models. So, and then we distinguish between what attackers can do, and this sometimes goes into just observing, for example, model parameters and training, or even actively manipulating or changing them. Attackers can also have different access from a total white box access, what means that they can access the whole model and all the parameters, to a black box access where they can only see the model predictions. And of course, a more realistic setup is a black box setup because oftentimes companies deploy their models behind APIs. So in a black box setup, you have the model and you can only interact in a query and then answer fashion. And a very popular attack in this setup, especially for models that have been trained to classify, is the so-called model inversion. And in model inversion, it's about inverting the model back to the training data, as the name suggests, namely to a prototype of each of the classes that the model has been trained on. Imagine you have a training data set like MNIST, which are these little black and white digits here, and you train your model on those. And what you then do is to invert the model and to get some like prototypes of how each class looks like. And this is bad because then the attacker can really know what is the distribution of your training data. And it becomes a privacy risk if you have classifiers that are, for example, trained to predict individuals based on their faces, because then one class is really one individual and like the different face images, and the prototype will resemble that person's face. So this is a real privacy risk. And how you can do this model inversion is that you start by giving the model a random input and then you get the output of the model from that. And let's say we want to invert a prototype for class 5 here. What you then do is you look at the confidence, and at the beginning, maybe the model is not very confident that this is a 5 because it looks just like random noise. What you then do is that you do back propagation, but you don't back propagate over the model, but the model is fixed, and instead you back propagate over the image. So you would change the image such that the confidence for the class 5 would increase afterwards. And this then slowly but steadily gives you a denoised version of your image data point, and the confidence gradually increases. So until you then have this kind of good prototype, and the privacy of this data point becomes increasingly broken. Are there any questions about model inversion so far? Otherwise, I'll hand it over to Adam for the next topic.
So we can, there's a question.
Oh yeah, there's a question about the dataset. If you want to just unmute yourself and ask your question, maybe that's the...
Okay, just check. Mm.
The question is whether we give the data sets at the beginning of the hackathon. Yes, like it depends on the task. For some different tasks, you will need data sets. For other tasks, you will need models. But everything will be provided to you from the beginning of the hackathon. So you will get a thorough task description for every task. And with this description together come links to all the artifacts, which are the trained models and which are the methods or the data itself. And this data then is also provided to you on the compute cluster. All right. I hope that clarifies the question, and I think we can move on.
Okay, great. So now we can move on to the second aspect that we want to discuss today, which is about data provenance. So let me go through the general aspect of what we really want to do in this task. So overall, the goal is that we want to find out what data actually was used to train the model in the first place, and actually also ask the question which data actually was generated by the current generative models. So what is really happening is that nowadays these models, for example, like GPT models from OpenAI, they are able to generate high quality text. And not only text, they can also even solve some difficult mathematical problems. What's more, models like Stable Diffusion 3 from Stability AI are able to produce photorealistic images. And finally, also there are even models for music generations that can cater to specific mood and generate these specific tunes for us. Now, from the perspective of these models, how they are really able to provide us such a high quality output. So the fact is that these models are trained on a humongous amount of data which actually escaped from the internet. And these training data are very diverse and they include, for example, the news articles like from the New York Times, also the books, for example, like Harry Potter, also the visual artworks, and also pieces of music. So all of this data actually is needed to generate these high quality models. However, what is really happening is that as the generative models are trained on this massive internet data and also generate high quality content, then actually this inputs to the models in terms of the training data and the outputs from the models, they form what we call, as of now, data loops. So what is generated at some point can be put back on the internet and then scraped and reused to train new models. This is how we create these data loops. What's more is that recently, together with our students, we actually discovered that these image generative models can memorize and then reproduce pixel by pixel their training data. Similarly, this was also the case for LLMs, where they were showed very recently to memorize the whole books, for example, like Harry Potter book by Llama 3.1. So we have this very concerning aspect that these models like GPT and Stable Diffusion, they require humongous amount of data of different type, but at the same time, they can generate this specific copyright content. So this actually is currently a concern in many countries. There are more than 25. As of now, we know that even maybe 60 ongoing lawsuits. And one of the most famous ones is, for example, between OpenAI and the New York Times. So, what are really the consequences of this whole process? So, the fact is that the copyright content might go into the models. Second is that these models can generate photorealistic images, high quality text, and also this actually can be some fake content that then can be pretended to be an original or real data. And then this high quality data can be then put back on the internet and used to train the models. Actually, it was shown that if you train a model on only generated data, actually degrades the model performance. So there are many things that we have to really understand about this process. And specifically for us, the most interesting task is to find out what data goes in the model's training set and also what data the models generate. Now, it's not only concern for us, but also even for the EU. So it is one of the important aspects in the EU AI Act, so that we are able to report what data goes into the models training sets, and also we are able to track what images or text were generated from these models. So what are the key challenges of the data provenance, identifying the data in generative AI? So first of all, we would like to find out what are the training data used to train the models. Also, then we want to understand what data is memorized by these models. And finally, what is generated by these models. So let me describe one of the most important tasks that might be of interest for this hackathon in Stockholm. So given an image, we ask the question, what was really the source of the image? So here you have many possibilities. You are given some form of models, for example, Stable Diffusion 3 from Stability AI or other models like that. Or for example, you might classify a given image as being an artistic content generated by a human being. Or maybe this was another generative model, for example, a GPT DALI 3 model, or maybe other source of such beautiful images. So the task here is to identify the either a model or classify the image as being human generated or maybe from other source. And then this is one of the, for us, important tasks to be able to identify the source of the generated or created image. So this is the general concept of what kind of issues we encounter with generative models and what we would like you potentially to work on. Now, we would like to give you a more technical aspects, but before going into the technical details, we may be also pause for a second and answer questions if there are any. So if you have any question, I think the best would be if you just type the question in the chat so that people can also see and we can discuss it. We can just wait for a few seconds more. Okay, so I think there's a question. So the task is to identify whether an image was made by a human or an AI. It's a very good question. So here, even in this simple example, we also have even more, let's call it classes. So one class indeed is a human being, for example, but here usually we are interested in more models than just one. So we don't want to classify binary. Is it human generated or AI generated? But we also would like to then find out if a given image comes from this or the other models. So in this case, the class generative AI can be split into many different subclasses, so many different models. To give you a specific example, so you might have these images, for example, that come from models such as Stable Diffusion 3, Stable Diffusion XL, also models such as Infinity, var, and then we ask you which model exactly this image comes from.
Maybe to also just clarify, we are not giving you the tasks for the hackathon today. So today is a background session. So the tasks from the hackathons are very much related to what we're discussing here today, but this is not a disclosure of the tasks, but the tasks that you'll be solving during the hackathon will be announced during the introductory session at the hackathon. But if you want to prepare yourself, this kind of background information here is very helpful for you.
Mhm. Are there any more questions? Okay, I think that if not, then we can move on. Okay, so now let us give you a bit more background into what kind of models are worth investigating or worth learning about before the hackathon. So here we focus on image generative models. We here discuss SOTA, state-of-the-art models that are currently the most powerful, the most popular ones, and that you might actually encounter the outputs from. So, what really changed in the vision domain recently was that probably most of you heard about diffusion models. So, this was one of the mainstream type of the models. However, these days, what actually is more powerful in terms of the generation quality and speed are models that are actually based on autoregressive generation. So this is similar to what is in large language models that you give to a model some prefix, for example, she ate an, and the model completes an apple. So model completes these words or tokens one by one. And what's happening now in the image generation is that we have a very similar paradigm of next token prediction. So here, what we show is a visualization of this image generative model that the generation of the given image starts from the resolution R1, and this is a general concept, what we would like in the image. And then with the next steps, R2, R3, R4, we slowly get more details into the image, and finally in this R sub k, in the last resolution, we are able to see exactly details of a given image. So we generate these images with higher and higher resolution one by one. And how these models are trained? So we start the training from the first part of um, autoencoder, where we would like to, in a way, um, compress the image from the pixel space to the latent space, then operate in the latent space, and finally go back to the pixel space. So once we have this compressed latent space of the image, then also the second part is to train a var transformer. In this case, or in general, it is some form of autoregressive model, autoregressive generator. And in this case, we operate on the tokens for the given image. So you can imagine that an image is represented as a bunch of tokens, and then for the given prefix of tokens, this var transformer, in this case, autoregressive model, generates the next tokens and eventually the whole image. So let's go a bit more into the details, how this autoencoder works and also the latent generator. So here in the stage one, we are given an image, in this case of a cat, and we encode the image. So we go to this latent space. So we go from basically the pixels to some latent representation. We also call it the feature map, F, which is of lower resolution usually than the resolution of the whole initial image. And then we actually tokenized this latent representation, and we express this image as the collection of tokens. And this collection of tokens comes from a certain dictionary, which we call a codebook. Now, once we have these tokens generated by the model, then actually we can still collect them into the latent representation, and then through the inversion of the encoding, so we now decode the image to the output space where we show the image of a cat back into the pixel space. Now, let's talk about how we really generate these tokens for images. So here we start generating the images from just start token being token S. Then we put this token into the autoregressive model, and the model predicts the next resolution, the first one here being R sub 1 hat. And this is what is predicted by the model, and we compare what is from the expected, so what we know about the image, what it should be for the from training set. We compare these different resolutions and compute the entropy laws to train the autoregressive model to be able to predict better this next token, these next resolutions. And we repeat the process. So then we put as prefix our start token S and also resolution R sub 1. So this is our prefix. And then we ask again the model to generate us the next token. In this case, the next resolution R sub 2. Model generates this resolution R sub 2 hat, and we compare it with ground truth, what we know from the training set, compute the cross entropy laws, and again train this autoregressive model to generate better the next time. So this is the background that is worth also learning before the hackathon to be able also to work on the state-of-the-art problems to detect which model a given image comes from. So are there any questions regarding this background on the latest image generative models? Okay, thank you for the question. Can you explain more the purpose of understanding the model internal of an var for the hackathon? Yes, so as we mentioned, we don't really say exactly what are the tasks, but what is the goal is that through understanding of how the model works, then you can also better identify what kind of images a given model generates. So in this case, knowing, for example, that a given model has specific dictionary, you might be able to identify actually if the given image comes from this dictionary. So through understanding of this background internals of the models, you have a better, more precise tool to identify if a given image actually was generated by this model. Okay, it's a great question. Okay, so I think for now we can move on, and if any questions pop up, we can
I
just
will monitor the chat,
yes.
yeah.
Okay. So once we know the background, what you can expect, what kind of knowledge is worth learning before the hackathon, the other aspect is that we work here on the cybersecurity and AI. In many cases, currently, the important aspect is to be able to compute, to find out the solutions through usually quite advanced hardware such as GPUs. So let us describe a bit more about what kind of infrastructure will be there at the hackathon so that you can actually leverage that to solve the tasks. So actually in this hackathon, we'll be using resources from Jülich Research Center. They have a really impressive number of GPUs, and they were so kind to also help with this European Championship and prepare this infrastructure for us. So we have, in short, many 800 GPUs that actually is at your disposal during the hackathon to solve the tasks. So what is very important for you now is that you see these slides. Also, we send to you a link on Discord where you should just click and register at Jülich and then also log in into this latest project 2601, and then you can just try out a few things and be prepared for the hackathon to use these resources. So just you can we also send these slides afterwards, or do send these slides also beforehand, so you have all the resources, so you can just follow them after the presentation and finalize at least the step of accessing the GPUs for the hackathon. So just go to this website and then register. What is also very important is that you have to accept very specific conditions. And here you just read through them as usual. And apart from just having a login and password, also we use authentication. So here you can use your favorite tool. For example, I use Google Authenticator, but you are free to use any authenticator that is your favorite one. And actually, this is second factor authentication. Um, another aspect is that there is also agreement, the standard thing. So the point is that we would like you to work on the task with hackathon. So you just have to read through that to understand more what we expect from you by using these GPUs. I think there's a question, right?
It's not a question, as a person having difficulties. I think for individual difficulties, reach out on Discord.
Yes, actually, also then we can also assist you better on Discord, and now we can just explain general concept, how to access and use these GPUs. Okay, so the best way to access the server is to use your public key. So if you don't have SSH key, then you can just generate that. If you have already your SSH key, you can just upload this SSH key to the Ulyss interface. And now, once you do that, please just copy the IP addresses from the shown here field to the additional public key options, and then just add your SSH key here in the red box. Then usually there is some waiting time, but it's very short, up to 15 minutes. And then once we update the servers on Ulyss, then you will be able to access all the servers. Now, how to really connect to the Ulyss login? So once you go through all of these steps, then you have to just SSH, specify where is your private key, and then you also have your login from Ulyss. So once you create the account, and then you can just use this jureka.fz-ulyss.de address, and then from there you can just access these servers. So usually what we observe is that most of you use some form of tool for writing your code. Most of the students use Visual Studio Code. So then here is a short intro to how you can use Visual Studio Code for the hackathon. So the most important thing first is to configure SSH hosts. So you have to just add Ulyss to be able to connect directly from VS Code to one of the login nodes at Ulyss. So you just have to configure. So you just go to this bottom left corner. You just want to connect by SSH, and then once this menu pops up, you just click on configure SSH hosts, and here I recommend changing one of the standard paths where you have the configuration of SSH. And then here we have an example how you can access these Ulyss servers by using this specific config. So here you have to change also the user. So this is my username, but you have to just change to your given by Ulyss. For those of you who also are on Windows, then you can specify Mac S, and then actually this is one of the ways how you can have access to your servers without any issues. Okay, so once you configure that, you can just again click on SSH connection and then choose Ulyss servers. Then you can open a terminal. In the new terminal, you can activate, in this case, a specific training project. So for our hackathon in Stockholm, we are assigned project 2601. So you are supposed to, at the beginning of the session, once you log into the Ulyss node in the terminal, you just type jutil environment env activate -p training 2601. Then we also have specific variables. such as dollar $project, dollar $user, and then through that you can easily go to the space where you have enough storage to, for example, store the results of your experiments. And then we also, during the hackathon, give you the specific GitHub repository where we'll put actually the task for the hackathon. So you can just clone um, this repository and then get all the tasks to your laptop. So then we have something like sample submission. So you can just check out how to submit a task, a solution to our scoreboard. And then during the hackathon, also we will distribute the API keys. So each team, each actually user will also have a specific API key that actually verifies that this user belongs to the specific team.
There's one question that asks you to explain once again what happens after the registration and the GPU using.
So after you register, then you have to also join this project, Training 2601. Also, I send the link on Discord. Once you join the project, as I described, you just go through these slides, you upload your SSH key, you agree to this specific agreement that is sent by Ulis. And then once you go through these formal steps, eventually you will be able to SSH into the Ulis and access the login node. And during the hackathon, actually, we'll be given resources. So only then you will be able to fully use the GPUs from Ulis.
Okay. There are other people with technical difficulties. I think on the Discord channel, we have an extra channel which is about technical questions. And I think you can exchange there and we will collect that. And if the problem occurs or like is persistent for everyone, then we will reach out to the like Jülich administrators who can help us fix that before the hackathon.
So this is uh, something that we will have more time to help you on Discord, and we are more than happy to also assist you with that.
The good thing is we have roughly 2 more weeks to figure that out. So just let us know, maybe screenshots and like error messages that you occur, like that incur in the problem in the process, and then we can like forward that to the administrators and they will help figure out the problem.
Mhm. Okay. So what is important is that, okay, let me maybe go here. So you also get API keys. Then also what we usually use for the projects nowadays, UV, it's a replacement for Conda or other such tools. So this is a tool that enables you to download and use packages in a very fast way. It's really blazingly fast. Also, we recommend addition of three lines to your dot bashrc file. So over there, you can also specify these exports, and this helps you with the development during the hackathon. You can also do it through that. It's a bit easier, I think, if you just copy exactly these lines and paste them into your bashrc. Also, these are additional comments that will be of use, especially during the hackathon. I think it is something that we recommend now using, so you can also get familiar a bit more with UV. I think it helps overall with the Python project, especially for AI and cybersecurity. And here is an example of main.sh file. This is actually for the Slurm. So the Ulis cluster uses the Slurm system for managing the jobs. So when you submit the job, you want to access, let's say, 4 GPUs, then your way to do that actually is by using this bash script, where you specify exactly the script that you will be running, in this case, sample submission.py, and also what kind of environment you would like to use and resources. And then you can just run sbatch of the main.sh. So sbatch just activates this batch job and then enables you to run this job on these GPUs. And here, once you go through that, you can just see all these GPUs that will be there for you. during the hackathon. So now regarding these questions also in the chat, so now is the time really for you to just prepare a bit. So you don't have to run any job. It's more about that you through these steps you will get the access to the GPUs now. You can try it out a bit so that once it comes to the hackathon you are prepared, and then you can hit the ground running and start working on the task instead of just dealing with the environment and figuring out how to access the GPUs. And then I think that we can just answer any remaining questions, and we'll be happy to also later on answer more questions or explain in detail how to access the ULIS infrastructure also on Discord.
And also, just to add up on what Adam said, we observed that the teams who are prepared, basically, who have just looked once through, like, how do you run a job over a bash script? How do you install a package with UV? Those are significantly faster in the tasks. Other teams that are not prepared, they usually lose the first 2 hours getting started. And so here's basically your big advantage. If you walk through these steps once and just have an understanding of, like, what needs to be installed, how can you run code, then you're ahead by 2 hours.
Mhm. Additionally, also after this session, we'll send also links to the papers that are very much relevant to the tasks that will be that you will be solving during the hackathon. So actually, reading through these papers will also help you to prepare for the hackathon. And we strongly believe that one of the most important things is that you learn a lot about what are the problems of current AI and also cybersecurity. And after this hackathon, also you will be able to uh, say that I learned a lot, and now I know what are the problems of this secure AI, and potentially how to maybe solve some of these problems.
Maybe we'll wait another 2 minutes to see if there are any questions in the chat popping up. So how to find a team and how are the pigs how big are the teams generally? So like usually or often people apply directly in a team with their best friends or with their study mates. We do support the option to find a team through us. On Discord, we do have a separate channel where you can find teammates if you're not yet in a team. So this is possible. And the teams are usually 3 to 4 participants. Anything less, I think you don't have a chance really to compete against the teams with 3, 4 participants because they can just divide their work better. So if you are a team of 2 people and looking for another participant, maybe like you can look in the participant channel and to recruit one there. Or if you do not have a team at all yet, just put your name in the room there and say who you are and that you're looking for a team. And then you can make a match together on the spot.
Also, actually, we saw on Discord that many of you already wrote that they're searching for a team, or that they want, for example, 1 or 2 more members of the team. So I think as of now, the best way to find potentially a team is really to use Discord. Where will the slides and such be posted? So again, Discord is our communication tool. So also after the session, we'll send the slides to Discord, and uh, any other information also will be shared there. Uh,
Yes, you get a recording after the session. We're doing this recording and then we'll upload it and share the link with you on Discord.
okay, yes, I can do that. So let me just post it. Mm. Okay, so I send the current link to Discord. So please go ahead and join Discord, and you will directly, I think, be able to just access the server. Okay, so I think that we actually see on Discord that there are some errors when you want to register. Also, you can actually specify if it's difficult. So it's actually difficulty registering to the Julish infrastructure. So we'll investigate that, and we have to probably contact people and Julish and find out what the problem is. Hopefully, it's just uh, temporary error, and then we'll let you know once it is resolved. So thanks for also checking it out, and it should be solved very soon.
Thank you for this positive message. We are also very much excited to meet you all in Stockholm. And in the meantime, please feel free to reach out over the Discord. All right. Otherwise, thank you so much for being here in this late hours and have a great evening, everyone. Bye.
Thank you. Bye. So there is also one more question. Very good. So I have a question that we have to come from Karlskrona. Do we get any sponsorship for tickets? So this is also why we come to Sweden. So we want to be there in person. You don't have to go to, for example, Germany or other countries. So um, you are responsible for your travel to Stockholm, and then for the top three teams that advance to the final of the competition, then actually we sponsor your travel to Germany to attend the final. So for the local championships, since we go to the specific countries, then we don't sponsor individual trips from your home to the regional event. Thank you also for asking these questions. We are happy that all of these issues are clarified. Okay, so the question is, what was the schedule on the morning 14th? When does the hackathon end? So let me maybe go back to this slide where we presented the schedule. So on the so hackathon actually starts on Saturday, which is 14th of February, and ends on 15th on Sunday. So usually the announcement of the awards and the results are at 3 p.m. So hackathon ends after 3 p.m. on Sunday. Um, yeah, so this actually is the standard schedule for all the regional hackathons. And also we expect the same schedule to be for the final in Germany. Okay, thank you for asking. So I think that there are no more questions. So again, thank you very much for attending this session, and we're looking forward to meeting you in person in Stockholm on February 14th. So see you and bye.